Okay, welcome to this video. In this video, I will be talking about question number 42 from the homework in section 5.1. I saw as a lot of you did this problem, you ended up with an answer that was somewhat correct or close to being correct, but it wasn't quite right. The answer in this case is that there are infinitely many solutions to this system, but just saying that there's infinitely many is not quite enough. You need to describe what the solutions look like, and it's not all real numbers, as some of you said on your homework as well. And so I'm going to walk through just how you would go about doing this problem. Okay. So we've got our system here. It's 25x minus 75y equals 100. And then negative 10x plus 30y is equal to negative 40. Okay, and so this is our system of equations. What I would probably do first with this is there's kind of a common factor between each equation. So the top one, you'll notice this is 25, this is 75, this is 100, right? So 25 is a common factor of all of the coefficients here. So what I would probably do first is I would take that and I would divide by 25. So I would divide by 25 just through the whole thing, and that would give me a new system. I would have x, and then 25, when you divide 75 by 25, we get just 3. 3y is equal to, and then 100 divided by 25 is 4. Okay, so that's what that first equation transfers into. The second equation, if you look at it, you'll notice there's a 10 in everything here, right? 10 divides into each thing, so I'm going to divide all of those, not by 2, by 10. Okay, so I'm going to divide all of that by 10, and when I divide that by 10, I get negative x plus 3y. This equals negative 4. Okay, now you'll notice here, even just right at this step, these two equations are essentially the same equation. But to maybe see this a little more formally is if I we'll do an elimination, because these two, this negative x here and this positive x here, those are going to be opposites of each other, right? And so I can just add those two together and get rid of the x's. Okay, so I'm going to just add these two equations together. Add those together. These cancel out, but you'll notice these also cancel out. Okay, and I get 0 over here, and this is equal to, well, 4 plus negative 4 is 0. This is a true statement, right? So there will be infinitely many solutions. Essentially, what this means is these two equations are the same thing, right? They describe exactly the same points, and so when I graph them, if I were to like actually graph them out, maybe that would be my first line. My second line would be actually the same exact line. Okay, the two lines would just be on top of each other. They'd be the same line. Okay, and so that's why there would be infinitely many solutions here. Okay, well, it's not, the solutions aren't all real numbers, right? The places where these lines intersect is not all of 2 space. It's just the points along this line, okay? So I just need a way of describing the points along this line. And so the points along this line are, well, normally how you describe a line is with an equation, right? Usually a y equals equation. So I'll take maybe one of these and solve for y. So I get x minus 3y is equal to 4, and I'll solve this for y. So I'll subtract over x, and then I'll divide by negative 3. So I get negative 4/3 plus 1/3 x, just dividing by 3, okay? So that is the actual equation of this line, okay? So that represents all the points on the line. So how I would write my final answer is what I would do is, well, the x coordinate can be whatever I want it to be, but the y coordinate will be given by this equation right here. So my final answer would be the point, any x value you pick you can do, so any x value, and then the y value would be negative 4/3 plus 1/3 x. Or sometimes in the book what they would use is, instead of x, they would use t, okay? So they would write their answer like, they'd essentially set x equal to t, and then write it like this, okay? But it's the same idea. It doesn't matter what variable you use. So this is our final answer, because there are infinitely many solutions, but they're all along this line here, okay? So it's not all real numbers, okay? Hopefully that's helpful. I'll see you in the next video.